Hello, everyone. Welcome to the very first of this year Digital Summit for the HCLS Summer Camp. We are focused on updates from IO. I'm Amy Waldron. I'm the Executive Business Lead for Healthcare and Life Sciences, and I will be your camp director for all four of these sessions. So look forward to everyone joining us, and would like to introduce the other counselors for this session. So today we are joined by two amazing clinicians, Dr. Pete Clardy and Dr. Justin Chen. Pete leads our clinician enterprise team in the development, evaluation, and platforming of machine learning and generative AI tools. He focuses on healthcare and life sciences and really helping organizations analyze and transform multimodal health data. He and his team, including Justin, work with a lot of our internal groups, DeepMind, Research, and Cloud, to create scalable tools to help organize and understand biomedical information. Before joining Google, Dr. Clardy served as the medical director of intensive care at BIDMC. He was the associate dean for medical education at Harvard and the chair of the Department of Medicine at the medical education at Mount Auburn Hospital, where he also helped coordinate COVID-19, their pandemic response. So as you can see, Pete has seen firsthand what it's like to be on the cutting edge of medical technology and the challenges of not only being on innovation, but also using that information in a very practical environment like many of you guys are working in today. Dr. Justin Chen is also with us. He's on Pete's team. He focuses on applying our technology in the life sciences environment. He also works with DeepMind, Research, and Cloud to help create scalable solutions that accelerate the scientific discovery and improve patient outcomes in the biopharma space. Before joining Google, Dr. Chen held roles in clinical development for novel therapeutics and medical devices, and is a practicing oncologist who is triple boarded in internal medicine, clinical informatics, and medical oncology. Dr. Chen brings a bedside to pharma perspective on the challenges of integrating new technology into the industry or the clinic. So at Google, we focus on, as many of you guys know, organizing the world's information and making it universally accessible and useful. As we think about doing that in a healthcare environment, we put a few more lenses on top of that. We look at really the nuances of privacy and compliance, and what does that mean to take on that role of organizing the world's health and life sciences information, making it not only universally accessible, but also making it secure and useful. So what you're going to hear today, and also through some of the sessions this summer, is how we actually leverage the research and technology and make it useful in the healthcare and life sciences environment. So before we dive into the topics, I just want to give you some camp rules. We try to keep this very informal. I know some of you are already using the in-call messages, so if you don't have that box, please pull it up, because we want this to be informal and we want to get questions and answers taken care of throughout the session. From a recording standpoint, this is being recorded, so we will be sending out the recording at the end of the summer camp sessions. If you pin the slides, just to make sure that you can see them for the best viewing experience, they should be pretty large right now on your screen. If not, please pin them. The Q&A, you can feel free to ask those questions in the message box on the right-hand side. And then please also make sure, if you're not speaking, that you're muted. So right now there should just be a few people who are unmuted, the speakers for today. So again, if you have any questions, please feel free to write them up in the in-call messages, and I will help moderate and answer those. So will Pete and Justin. So our topics for today, okay, a lot went on at IO, as many of you know. So Pete, Justin, and I kind of came up with what our top four are. So with that said, I'm going to hand this over to Pete, who's going to walk through the four that we've chosen, and then we're going to do a deep dive and hopefully get to see some fun demos.
Excellent. It's really great to see everyone on the call. Thanks, Amy, for the warm introduction. It's great to be on our first of the season and to have Justin join me. A little bit of maybe broader context. I think Amy did a fantastic job in sort of introducing the work that Justin and I do, but Maybe just for a little bit of context, we work on the health team at Google under Karen DeSalvo, and really work to bring the best of Google research and things that are forward-looking to our enterprise partners through Google Cloud. And so on our team, my area of focus is critical care. Justin is an oncologist. We have other people in other domains, but a lot of what the team does really relates to, I think, themes that are probably common amongst the clinicians on the call, which is translation between the world of tech and the world of clinical care delivery. And so Justin and I spend a lot of our time both on the developmental side, sort of thinking about the future-looking tools that are being developed at DeepMind and at Google, and also increasingly focused on where can we now gain value from machine learning and more generative AI tools in all aspects of care delivery, operations, education. And so that's really the world in which we live, and a lot of the function that we play is as a sort of translator layer between the clinical world and the tech world. So with that said, I had a chance to go to I/O this year, and I/O is the annual developer conference at Google. It's held in May. It was about 6 weeks ago, I think May 20th, 21st, and it's an opportunity to really highlight some of the latest developments for the development community and more broadly of things that are happening at Google. There are hundreds of announcements, and I think the place I wanted to start is that the frontier models, Gemini, now Gemini 2.5 Flash, Gemini 2.5 Pro are in wide release, have continue to show sort of step function improvements in multimodal performance across a really wide range of tasks. So I think seeing how that's applied in different tools, we'll talk specifically about healthcare and life sciences, but seeing what these tools have meant for video generation with VO3, what they've meant for image generation, what they've meant for coding and other areas has been really impressive to see. And so that's been one area of focus. But I think the other area of focus is how some things that Google has been doing for a long time, like search, and other things that are much newer, like frontier models and the systems and platforms required to use them effectively and efficiently are sort of coalescing. So maybe the first slide is useful, and I promise we're going to keep the slides limited and would love to have a wide-ranging conversation. But I think the first slide, or the next slide, if Allison can switch it over, is a reminder of kind of this broader ecosystem that we now are sort of working and building in. So I think there's lots to talk about different frontier models and ours versus others versus purpose-built models or homegrown models. But one of the things that we're really seeing is that it all starts with data privacy and security. It starts with the ability to have kind of a composable orchestration of your data and the models into workflows. And I think that's a place where we've really continued to see a lot of composability for folks who are building, but also a lot of tools that are ready out of the box. And I think the themes that are really coming across are the frontier models are getting more powerful, and the barriers to entry, either for folks who have relatively limited experience and need an out-of-the-box sort of level of support, or for folks who are advanced or very advanced, and what they want to be able to do is fork off and develop their own bespoke models and or their own bespoke pipelines and workflows. I think what we've really seen is just greater composability across the platform. So I think that's one thing to focus in on. And then really as subsets of that, a lot of the places, and I'll have Justin speak to some of these where we've seen big steps forward in the actual application of these tools to real world problems, isn't a model alone. It is an unmet informational need, and then a combination of and often search within a restricted domain of information, and then large model summarization. And so that pattern of a safe and secure platform with data that is kind of preserved and isolated, then the ability to do both search and summarization in combination is something that we've seen a lot of really remarkable developments with. So as an example, lots of people are starting to use Notebook LM and other tools, but for lots of providers and various industries and areas, there is sort of a referential corpus of data. Those might be guidelines, policies, procedures, but those could be voluminous and really complex. And so finding better ways for people to use those tools in real time and in real world workflows has been an area of focus that combines a platform, search technology, and generative, often multimodal large models. And so I think the next 2 slides talk about a couple of examples where we've used that combination of platform, restricted set corpus of data, and then search and summarization to drive innovations in care delivery. So I'll turn this over to Justin.
Yeah, thanks so much, Pete. So just adding on to what Pete was talking about, diving deep a little bit into some of these use cases, Google and Cloud partnered with Seattle Children's to work on how do we better organize and synthesize information that comes from clinical guidelines. So for those of you that are not as much aware in the pediatric space, Seattle Children's has a really large corpus of rich text and non-text information for clinical guidelines in multiple clinical scenarios. And the challenge is always, when we're sitting there in front of a patient, how do we get information fast at our fingertips to make decisions quick and guide good clinical care? And, exactly to Pete's point, it was about understanding the users involved and ultimately what that outcome was, right? The outcome is to try to drive better patient care, but also to try to free up the physicians and providers from a lot of that administrative burden. And so the way this worked is an AI agent built on top of Gemini that really supercharges the search and the summarization feature to surface information in a really quick manner. And I think the statistics sort of speaks for itself as far as like a 96% reduction in time to access. So really like trying to reduce the number of clicks, right? Like we talk about clicks a lot in the clinical pathway. That's what this was trying to do. And then downstream of that, you can make better decisions, think more about the patient, be in front there at the bedside, and ultimately drive those outcomes. On a very similar framing of this, Google Cloud and Google have worked with ASCO to create this guideline assistant. And so this was recently launched and announced at the ASCO annual conference. So for those of you who are not familiar with ASCO, it's American Society of Clinical Oncology, one of the largest medical subspecialty driven organizations. The A is probably a little bit of a misnomer because it's truly an international organization. And really the same concept applies here, right? They publish clinical guidelines for a really complicated field like oncology with a lot of different use cases. And the challenge has always been, how do you surface the right information at the right time for the right case in front of you? And the reason we wanted to talk a little bit about this, in addition to what we did at Seattle Children's, is it gives you a different understanding of sort of the ecosystem involved. Seattle Children's is more of that provider-facing healthcare system, whereas this is a large international organization that thinks about oncology and setting global guidelines. And so 2 different flavors, same problem, same healthcare space, but one more healthcare system facing and one more agnostic to healthcare system.
And one of the things sort of on that previous slide, and one of the things about this pattern where you have sort of a set of kind of reference materials. And so I can see from the list that we have lots of clinicians, lots of folks from different areas of care delivery. You might think about policies, procedures, guidelines, directive, like every hospital I ever worked at has, their PPGD file, and it's usually complex, messy, and hard to find the exact pieces of information you want. And I think increasingly we're seeing examples of using these tools, search and summarization in combination, to organize that really complex internal data in ways that are highly secure, and where the users get to define the area over which search is conducted. The reason I also bring this up, and maybe for folks who haven't had a chance, Google has sort of publicly available tools like Notebook LM, which actually recapitulate many of these things. They are not designed for use with medical data, meaning private data, or scaled implementation, but they're a great way of exploring those tools. And in fact, that same sort of fundamental tool set that's available to the general public through Notebook LM as a way of sort of exploring your own data, we're seeing a lot of value from our partners who are doing that at scale within secure data silos to leverage some of that same data exploration technology.
And Pete, just to chime in there quickly, with regards to, and this is something that we're not covering here, but you might want to take a look if you're interested, being able to use Gemini and our search and summary capabilities across your enterprise information. So Pete's going to dive into like the EHR and what that looks like, but also we're seeing in the healthcare and life sciences space a tremendous amount of organizations using agent space, which a lot of what Pete talked about, like being able to have kind of one pane where you can connect into your enterprise data sources, still have that security element, the identity and access management brought towards you, but have the ability to leverage Gemini and search and summary capabilities across clinical and non-clinical information. And so, that gives you a pretty broad area, and also areas where you have kind of the access to first and third parties. So being able to use these capabilities, like it's really not limited to a small number of applications and data sources. We have connectors to over 100 different applications where you can securely bring those in and leverage these capabilities.
Yeah, I was going to add one other thing on top of that, which is like security is definitely really important. I think in healthcare, there's especially sensitivity around accuracy and fear of hallucination. And so a lot of the solutions we're talking about here really try hard to push that envelope to get rid of hallucinations essentially, and to ground things entirely on the corpus available in front instead of having things leak in through the pre-training, for example.
Yeah, and I think one of the other areas where we've been able to create some more healthcare and life science specific tools relates to things like search, where sort of we have, special tools for searching over medical records, as Amy mentioned, that are optimized for medical language, abbreviations, multimodality inputs. And so using those tools in combination with summarization has also been an area that we're continuing to develop with our partners. One thing to sort of shift gears slightly and to kind of maybe talk about things that are specific within healthcare and life sciences that are generally available, they were developed by Google, and I can explain a little bit of kind of where some of these tools came from. But what I'm going to talk about here, and what the QR code in the bottom right will take you to, is another area that we've actually been building on for more than 5 years, and sort of accruing tools and information and publishing in the literature, but really relates to the creation of open weights foundation models or families of models that are optimized for healthcare and life science data. So sort of trailing back, Google has done research at scale for well over a decade, really for most of the history of the company. And I started doing research with Google in 2018, and it was already well established in terms of Google Brain, focusing on using AI for health and life sciences. And so early tools included machine learning, basically computer vision algorithms focused on things like pathology, radiology images, dermatology images, and in addition to other areas, which I'm not talking about today, but things like AlphaFold were kind of built and resulted in publications, but also resulted in these open weights tools. And so we've really tried to make our foundation models in pathology, chest x-ray, CT, dermatology, and lung bioacoustics, and I can talk a little bit about that last one, available, meaning open weights models not only on Google Vertex, but on Hugging Face. And with these machine learning computer vision models, we also publish sort of the relevant information, including sort of model cards and sort of collab notebooks that can be used. And then these tools can be used out of the box or in combination with other data sets. So if someone wanted to create their own pathology, chest x-ray, dermatology model, they could use this as a foundation. And so we've continued to lean into the development of these tools that are specific to certain imaging modalities, and that continues. But some of the most exciting things that we've seen over the last, say, 12 months and really accelerating over the last 3 to 6 months is the development of distilled models. Distillates are models that are really taken from Gemini, the sort of frontier model, and distilled down for capabilities in specific areas. Some of them are relatively vanilla. They're just designed to be smaller and easier to build with. But some are optimized for things like robotics or coding or other specialized solutions. We've now made available as open weights models MedGemma, which is a family of models focused on therapeutic drug development. And so structure, toxicity, function, disease relationships, names, taxonomies, all of those things are sort of included and enriched within MedGemma. And so that has been made available and is now being used by our partners and by people who want to take advantage of those tools that are openly available. And more recently, we have published, and including a very, very recent technical report that just came out this week, MedGemma. And so MedGemma is a distillation of Gemini based on a lot of early work that we did. People may remember research projects like MedPalm, MedLM, MedGemini. So a lot of the applied learnings from our historical work have been taken and distilled into MedGemma, which is available in a 4 billion and a 27 billion parameter size, one for multimodal, one for text only. And so we're now sort of, again, publishing not only the models, but the collab notebooks, model cards, and the associated tools that would be required for building with MedGemma. So I think what's exciting here is, again, sort of this theme of lowering barriers to entry and making tools available for folks who are building in this space, who need to have high quality foundational models from which to build. It also opens up the ability to work locally rather than to have inference served, for example, from a data center. I can see Amy has her hand up, but I'd also be glad to circle back to this slide and these concepts.
Just super quickly, we've got some questions, and one's very relevant to this. There's a question about hallucinations. And
Yep.
I know we have come a long way. If you look at the last year and a half with regards to grounding and prompting, can you please provide some perspective on what people are doing and what we're doing with regards to that topic?
Yep. So I think I'd answer it in a couple of different ways. One is that it's probably good to think of hallucinations as something that we mitigate rather than remove. I always get nervous, if we if you hear that it's like completely solved, that there are non-deterministic ways in which the models work that make us need to always be vigilant for things like hallucinations. That said, what Justin pointed to, which is this combination of grounding where sort of every statement is associated with a source on an atomic level, so you can sort of investigate line by line, is one step in that process. The development of reasoning models that are essentially auto-checking on an atomic level for everything in a statement is another way that we're sort of seeing the frontier models start to address, or I guess mitigate, the issues of hallucination. So I think one way to think about it is that the models do have reasoning and other tools that are now increasingly built in to mitigate or decrease the risk. The other way I would answer that question is for something like MedGemma or some of the other open weights tools, because these are models that could be applied to really an infinite number of different use cases, we can't evaluate across all of them. But what we do is take certain areas, say medical question answering or visual question answering, and then look at those with our internal rating teams, folks like Justin and myself, with external raters who are drawn from a very wide geography so that we don't bias in one direction or another in a range of different specialties. And then we can sort of understand what are the performance characteristics of this model with this particular use case in mind. So I think that's really the way that we can kind of assess on a case-by-case basis. But I think that these problems will probably never completely go away, but that what we're seeing is much improved outputs and a much better ability to investigate each statement at an atomic level to understand why the model is creating the output it's created.
Thank you.
This is really just sort of an overview of kind of the ways in which these models are built. And you can sort of get a sense that a lot of the things that I talked about in terms of understanding radiology images, dermatology images, pathology images can get folded into a system that also has large language understanding of, or large model understanding of language. And so in a lot of cases, the way these models are built and developed is essentially reinforcing the overlap between the words and images and developing and refining models in that way. And so to this earlier question around things like hallucination or like, how do you know this is a better model than that model or better than before? These are some of the areas in which we've run analyses for MedGemma. And again, the 27 billion parameter technical report, I think, was just released on arXiv this week. So I think we're continuing to understand the performance characteristics, but we're also learning from the larger community that's starting to work with and build with these models and starting to understand how they perform both on a cost and output or performance basis relative to other tools that are available. The other things that I wanted to talk about, and I'm really delighted that there is a group of a lot of translators, as I was saying, the folks who kind of live both in the clinical world and also in the tech world. And some of what I'm going to cite, and again, the QR code will give you the reference, is going from some of the early work that we did around using Gemini, or a sort of system of a mix of agents for medical diagnosis, sort of in a primary care setting, to looking at the use of these same tools for subspecialty care. So I'm going to just highlight a publication from Nature Medicine that came out recently. It was in preprint for probably about 6 months prior, from the DeepMind and Health AI research groups that have sort of been looking at, like, what does the what does the forward-looking frontier look like for some of these tools in care delivery, not just in sort of the organization or summarization of medical information. So the setup is outlined here. There are synthetic patient cases in breast oncology, one treatment naive, one treatment refractory, that are presented to the AI system, oncology attending, oncology fellow, medicine trainee. Those responses are collected and then evaluated by other expert oncologists. And so on the next slide, you'll see, it's a busy slide, but really what the goals were is to look at sort of the ability to sort of extract and summarize information, to come up with a safe plan, and sort of how the reasoning around medical management worked. And what I think we're seeing in most cases, and this study was paired with work that we've done in cardiology and other subspecialty areas, is that in most cases, the AI performs less well than the attending, but on par with or better than the trainee physicians. And there are some places where this difference is really pronounced. So for example, in things like neoadjuvant therapy or adjuvant radiation, the senior oncologists and the AI were performing at a much higher level than trainees. So again, I think suggestive and intriguing in terms of the direction of sort of where these tools may go in an assistive or supportive mode for clinical decision support. The next slide, I know there's a bunch of questions, and maybe we can take a moment.
I was just saying, there's one.
We're doing a bunch, so yes, maybe we can come back.
One last question. I think that kind of wraps up that section, because you've been answering a lot of them. Can you just, with regards to MedGemma and the work we've done with models, because we have spent, I say we, don't include myself in that group, you guys have spent years working on these models. It is not something that just came together quickly. Can you please share the diversity of the information that has trained these models and give some perspective, because it was no light feat by any means.
Yeah, no, it's a great and it's definitely worth a deeper dive. And I'm also glad to, if there are specific data types, but the history of a lot of the research that we've done, really all of it has come from collaborations. And so if you look at retinal disease, we've had long-standing, really beginning with Moorfields in the UK, but internationally, Vietnam, Thailand, India. We've worked with different medical centers and provider groups. And when we've done research, we've done it under the auspices of a business affiliation agreement, an IRB, a design study protocol, a clear sort of rationale. And so a lot of the original tools, the retinal tools, the all of the imaging modalities, language understanding for medical texts, all of those came from different academic efforts where we had an academic partner, a BAA, an IRB, and then a publication goal. The net result of all of that, and that those tools address things like use of ultrasound in under-resourced areas for maternal fetal health, use of these tools for screening at scale for diabetic retinopathy, use of these tools for expediting diagnosis of breast cancer. So for each, there was kind of a particular use case, endpoints, and again, they ended up covering a lot of different demographics and geographies. You can sort of think of all of those efforts in some ways as the things that allowed us to create the model weights for these other representations, and that those end up as part of the tools that we now have made more generally available.
Yeah, and another question that is answered, and I think you kind of just gave part of the answer, but there's a question of have these been used? That's I would say that the great thing that that I've noticed with our health group and with Google in general is that these are not kind of created in isolation. We actually have worked with medical institutions around the globe to leverage these models for early disease detection. And so by the time we actually roll them out, we have worked hand in hand with well-known organizations to stay close to these and to make sure that it's not just kind of within our lab. This is something very much so that we're working with organizations around the globe to make sure that the quality of output is acceptable, not only for us, but for key organizations around the globe.
Yep.
So should we
Oh yeah. Oh yes, and co-scientist. I have other thoughts on what Amy just mentioned, but for people who are interested, we've also done work on things like an Android developer kit so that community health workers globally can use Android operating system as a way of creating tools for recording patient data and understanding population health. Usually that's done on paper and it's logistically very complicated. The last thing that I'm going to sort of bright light is work that we've done on a tool called Co-Scientist, which again takes a little bit of a different angle on discovery and is less focused on, say, patient medical records or imaging studies or some of the things that have been central to what I've discussed already, but actually creates a series or a mix of agents, a bunch of different models that are each playing a different role in the developmental process as a scientist sort of pursues various research ideas. I think the next slide, again, is a little bit busy, but gives a little bit of the idea behind co-scientists, which is that a scientist is able to come with a foundational idea, with her ideas and review of that, the discussion of sort of constraints, and that can then be fed forward into this mix of agents where there is one agent or set of agents that is generating ideas, another set of agents that is evaluating and sort of cleaning up those ideas or evolving those ideas, ultimately sort of resulting in a tournament across all of these different ideas and hypotheses with a ranking agent essentially sort of presenting them back to the actual co-scientist, and that this process can be iterative and sort of run over time. And so this tool has now been introduced in sort of trusted tester environments. And what we have found is that the scientific teams with whom we are working have found it useful in deriving new insights on things like mechanisms of fibrosis, treatment pathways for AML, certain new ideas about mechanisms for antibiotic resistance patterns. And so I think we're really interested in sort of how these upstream tools might work alongside the scientific discovery process. And so this continues to be an area of a lot of investigation. Let me pause there, and I know we continue to accrue questions along the way, but I think the next slide,
we're answering
yes,
a lot of them.
I think we're probably close to the end, and this really just emphasizes that one of the things that's interesting about this is the iterative nature. So rather than getting sort of one set of ideas and that's it, with multiple turns, the co-scientist can sort of continue to evolve these hypothetical constructs for various experiments. Let me just see if there are high level and again, things that I can answer from the question group, or Amy, Justin, if you have input.
We've gone through a lot of them already. Like we've addressed them while you're speaking through. So I think we're good. We can go pretty close to the end, I think, with content, because we're getting to the Q&A kind of during. And Pete, do we want to demo anything, or?
Let's jump in, given the time, to questions. I just saw one. So the Android developer kit question, if you look under Open Health Stack, OHS, you'll find information about the OHS SDK or software developer kit that's really optimized for easy access and for Android, and there's a lot there, but I'm also glad to be available if there are particular questions about how to connect with those teams.
And Justin, there was a question about clinical trials. Do you want to tackle?
Yeah, I can take that one. I think that's clinical trials, really broad spectrum of things, anywhere from early drug discovery to actually delivering care at the bedside with patients. I think the question was around kind of like site management and more of the care delivery, physician provider facing side of things. That's definitely something we're very interested in and working with people on, but it's such a broad scope that you can really break apart a lot of these problems in multiple different ways. And so those are the things that at least I'm definitely thinking about and we're working with partners on. So just as an example, right? Like one aspect of clinical trials could be related to just creating documents and reconciling those. Another aspect could be more of an education piece and how do we get people trained, for example, or consented and do outreach. So there's just a lot of different ways these can all fit in. And I like to think of what we have as sort of the infrastructure and connective tissue that we can provide for people to address specific problems that they're facing.
All right, here's a question about MedGemma. So how good is MedGemma, the model for energy extraction and fire generation from text?
Sorry, entity extraction and what was the second piece?
Fire generation, FHIR, generation from text.
Yep. So I would say the technical report that's coming out, and let me see if I can find that, or we can put that into the chat, that just came out on Archive, is the source of truth that I would reference for that. And that looks at the 27 billion parameter model. I think that those are probably fairly different, meaning named entity recognition, I think, performs very, very well. If the question is sort of transitioning or serving as a translator into sort of fire mapping, that is a separate and somewhat more complicated question. Understanding sort of fire concepts, understanding concepts from a whole range of different taxonomies, that is sort of part of kind of how the family of models works.
And then here's another data question. So how is it with regards to, and I know we're working on a handful of coding projects, the extraction of ICD-10 codes and SNOMED codes? Can you share kind of how that's working with regards to search in Gemini?
Yes, so I think that those are kind of similar to SNOMED concepts, ICD-10, other coding concepts do exist. I think it's fair to say that those are sort of recognized concepts. How to use the tool at scale for sort of optimizing coding. I think we have done a lot in that regard. It depends a little bit on, and to Justin's point around clinical trials, like the specifics of the part of the process that you want to address. And there are a lot of different point solutions and ways in which the tools can be incorporated. So I think there's two pieces to that. Is the model capable across those domains? The general answer there is yes. Is there an easy plug and play that solves for, say, HCC coding challenges? The answer there is probably no.
Okay, and then these are some specific questions. Potential applications for dentistry. I know that we've leveraged a lot of the medical imaging in the dentistry space, but Justin and Pete, do you want to chime in on additional applications or potential applications in that space?
Yeah, so I have a couple of thoughts there and would welcome Justin's as well. I think that a lot of the things that we're seeing, and to sort of go back historically, we had equipoise on whether Gemini was going to be sort of Gemini and then like a health version and a legal version and a, maybe manufacturing version. And I think what the learned or what we've taken away is that these very, very large frontier models that are sort of designed horizontally are really quite capable across lots of different domains. And by extension, that some of the tools that we've developed that are sort of specifically medical have been useful in other domains, dental, veterinary, kind of adjacent. So I think it's always important to sort of look at the specifics and study it carefully. But as an example, we've used the foundation model in adult chest X-rays to improve the performance of a model of neonatal abdominal films for necrotizing enterocolitis. So even though the foundation model in chest X-ray wasn't trained on neonates or on abdominal films, using the chest X-ray foundation model with a base of neonatal films substantially uplifted the base model performance. So I think I would be reluctant to give sort of a blanket answer, like if it works for medicine, it works for dentistry, veterinary, other things. But I think there's reason to be optimistic that there's a fair amount of transference across domains.
All right, I know we're quick. I went one more question, but if we can slip to the next slide while I throw this question at you, because I think it's really important. They're all important, but how can we ensure HIPAA compliance with these models? And another one with regards to the data that goes through MedGemma can have PHI data in them. How is that handled to make sure it's compliant? So both very, very relevant topics. Can you answer that and then we'll wrap up?
So anything that involves PHI really needs to be run sort of privately on a stack, not through sort of general publicly accessible endpoints. So whether that means you can download and work with MedGemma, but you would, if you were going to be using PHI, it would need to be sort of within a sort of construct that allowed that to be done in an isolated way. And this is sort of what we do all the time with kind of using these tools on cloud, but it is not the case that you could just assume and sort of enter things in. HIPAA compliance is an area where, again, the tools that we platform at scale, we platform with very clear documentation, including things like model cards, HIPAA compliance, lots of different ISO and SOC compliance. And so there, I think the platform matters a lot. Model being HIPAA compliant, yes, but the risk is probably much, much greater in terms of leaky platform than leaky model.
And that's where I have to say, I mean, one of the benefits from a Google Cloud perspective is that all of these capabilities are actually inside our stack. So our customers that are on the Google Cloud platform and have their own private tenant, when they're using these capabilities, whether it's clinical or non-clinical data, their data is secure. And so that is something that, again, clinical or non-clinical, I think everyone has to be very, very cautious about, making sure that your data is not training models. So with that said, thank you, Pete and Justin and everybody. We have a great crew from around the globe. The next three coming up are on the slide. So hopefully you will join us for a few more of these. And again, we appreciate the activity with regards to questions and the conversations taking place on the side. And again, Pete and Justin, thank you so much for bringing your wisdom here. Nothing is better than seeing great research actually being applied in the field. So thank you, everyone, and look forward to seeing you later on this summer.